Hi, this is Alfauzi Nihar from At Home Tuition. Welcome to our session today. The topic that we're going to discuss in our today's video is the continuation of the previous video, vector manipulation review. So this is the second part. In our previous video, we have covered the basics. Now we are going to start with vector addition and scalar multiplication and how to perform the operations. In our previous video, we saw the properties of vectors like finding the position vector, magnitude and direction and all. Now that we understand the property of vectors, in case if you have any query, you can refer a previous video. Now we can perform operations involving them. So while it is convenient to think of a vector u equal to x comma y as an arrow or a directed line segment from the origin to the point x comma y, vectors can be situated anywhere in the plane. And sum of any two vectors, for example u and v, or vector addition, it produces a third vector which is the resultant vector u plus v. You should draw a line segment about that. So to find u plus v, we first draw a vector u from the terminal end of u vector. We draw the vector v. So in other words, we have an initial point of v which meets the terminal end of u vector. So this position corresponds to the notion that we move along the first vector and then from its terminal point we move along the second vector. So the sum u plus v vector is the resultant vector because it results from the addition of u. You can perform any operation, addition or subtraction, of u and v vector. The resultant vector travels directly from the beginning of u to the end of the v vector in a straight path. I'm going to show you the figure also. Vector subtraction is very similar to vector addition. So to find u minus v vector, view it as u plus, instead of v, if you substitute negative v, you'll get the same thing. Am I right? So adding the reverse direction of v and adding it to the end of u, the new vector begins at the start of u and stops at the end of negative v. I'm going to give you the vector addition subtraction using parallelogram. You can compare this visual with the previous one. Okay. So let's now see an example for adding and subtracting vectors. Here is an example. To find the sum of the two vectors, we should add the components. And to find the difference of two vectors, we should add the negative components of v to u. Okay. So let's now find for the given vectors u and v. U is 3, negative 2 and v is negative 1, 4. So for sum of two vectors, so if you add the components, you will get 2, 2. Let's find the difference of two vectors. I'm just going to add the negative components of v to u. So just subtract the component. So that would be 4, negative 6. Let me give you the visuals for both sum of the two vectors and difference of the two vectors. U plus v is 2, 2 here, and u minus v, u plus negative v is 4, negative 6. So it will be lying here. So this is how the visuals for both. Hope you're clear with this one. So this is all about addition and subtraction. Now let's move on to the multiplication. Multiplication by a scalar. While adding and subtracting vectors, it gives us a new vector with a different magnitude and direction. The process of multiplying a vector by a scalar means a constant. It changes only the magnitude of a vector, the length of the line. And the scalar multiplication, it has no effect on the direction unless the scalar is negative. So in which the direction of the resulting vector is opposite the direction of the original vector. If the scalar is negative, the constant is negative, it will just change the direction to its opposite of the original vector. Scalar multiplication involves the product of a vector and a scalar. Each component of the vector will be multiplied by a scalar. Thus, to multiply v equal to a, b by a scalar k, we have kv equal to ka, kb. See here, only the magnitude changes. Unless the k is negative, the vector will reverse direction. You can also think that if you're multiplying negative k, it will be changed into a negative number. Am I right? Okay, I'm going to show you how to perform scalar multiplication using an example. I'm taking an example where we can find scalar multiplication in different ways. Just multiplying by a constant, just like a division, half and negative. So given a vector 3, 1, let's find 3v vector, half of the vector and negative v vector. Okay, first I'm going to give you a geometric representation. So if v is equal to 3, 1, then 3v would be, I'm taking same 3, 1 and multiplying both by 3. So I get 9, 3. So this is the 3v vector. Let's now find the half of the vector. I'm taking the v vector 3, 1. Now I'm going to multiply both the components by 1, 2. So half of v vector is 3 over 2, 1 over 2. Let's now find the negative v vector. Just place a negative sign before the numbers coordinates. So I'm going to show you the geometric view also. This is how the vector 3v will look like, and for this one I'm going to show you v, half v, negative v. See, this direction has been changed. Hope you're clear with this example. Let me take one word problem. If the questions are very straightforward, it will be easy for you to proceed with the question. Now I have taken a word problem. Let's see how to do this. For a linear equation, to solve for the unknown quantities, one number exceeds the other number by 17 and the sum is 31. So find the two numbers. Okay. First we multiply each vector by a scalar, 3u and 2v. So these two numbers can be, if you add the number, you should get 31, and the difference between one is 17 more than the other number. So you can take 21 and one number should exceed another number by 17 and their sum should be equal to 21. So I'm going to take two numbers, 21 and 4. This number should be 25. Okay, first I'm going to take one linear equation, 3u plus 2v. First we should multiply each vector by a scalar, 3 times u, 2 times v. Let u be 3, negative 2 and v be negative 1, 4. So the scalar multiplication would be 9, negative 6, and for this one negative 2, 8. Now I'm just going to add these two together and create a linear equation. So if I add these two vectors, so 9 minus 2, negative 6 plus 8. The resulting answer here is 7, 2. So these are the two numbers. Hope you are clear with this example. Scalar multiplication is applicable in many places. Now let's move on to how to find the component form. In some applications that involves vectors, it is helpful for us to be able to break a vector down into its components. Vectors are comprised of two components. One is the horizontal component that will be in the x direction. You can imagine a graph. One will be in the vertical component. One will be the vertical component, which is nothing but the y direction. For example, consider this initial point and terminal point. The position vector for this initial point and terminal point will be 2 minus 0, 0 minus 0. That is 2, 0. Okay, that is the vector. I'm just taking two vectors which should be formed. The first one should be with the initial point 0, 0 and terminal point 2, 0. And the second vector will have an initial point 0, 0 and terminal point 0, 3. Let's now find the position vector for this one. So let me consider this as v1 and this is v2. So v1 is 2, 0. Let's now find v2 with the initial point 0, 0 and terminal point 0, 3. So 0 minus 0, 3 minus 0. So therefore the position vector would be 2 plus 0 and 0 plus 3. So that would be 2, 3. Now let's also find the magnitude of v1 and magnitude of v2. Okay. So for v1 you can use the distance formula how we generally find. So that is going to be 2 and magnitude of v2 will be 3. So let's find the magnitude of the vector v, new vector, using the formula with the position vector. So that's going to be, therefore the magnitude of v is square root of 13. And now we have got the position vector, magnitude, and now we are going to find the direction. For direction we use the tan formula. Generally we use b over a. Here we have two vectors v2 and v1. So I'm going to use v2 over v1 and take the tan inverse. So this would be equal to 56.3 degrees. Here is the geometric view of what we found, the position vector and the magnitude and direction. Okay, the magnitude of the vector v is square root of 13 and direction is 56.3 degrees of the horizontal. We just started the component form of a vector, and we still have to review how to calculate the component vector of a vector in the direction form, and we also need to review the topic performing operations on vectors in terms of I and j, and vectors in the rectangular plane, unit vectors. So these are the topics we have to complete in the review. So we can continue that in our next video. In case if you get any query regarding this video, you can let me know. See you.